Measurements in DC and AC circuits require the proper type of voltmeter to measure those voltages. In this example, I have a 10 megohm resistor that's connected in series with another 10 megohm resistor. If we look at 10 volts, and we take a look at the voltage divider formula, we'll find out that this should have 5 volts across it, and there would also be 5 volts across this one as well, because they're equal value resistances. They divide the voltage in half. So because of this, if this voltmeter has an internal resistance that's much lower than 10 megohms, it's not going to read correctly, because part of the current, although it's going through the resistance, is also traveling through the meter itself. All voltmeters have a particular internal resistance. Some are in the hundreds of thousands of ohms, which would look very almost like a short across this particular device. And there are those that have 10 to 22 megohms of internal resistance. For example, this portable multimeter, the digital multimeter, has an internal resistance of 1 megohm. This little bit higher bench type voltmeter actually has an internal resistance of 10 megohms. So if I were to use the 1 megohm meter across this, I would be sending a lot more of the current through the meter than through this resistor, because we can use Ohm's law to take a look at this. Because this is 1/10 of the value of the one that it's measuring across, considerably, it's going to have quite a bit of a drain on this particular circuit. With the splitting of the two currents, it means that there's going to be less voltage applied across this particular device. So if we put the voltmeter across here, it's going to affect our measurement. It will not be 5 volts, it'll be considerably smaller. This one up here might possibly get to be a little bit bigger. So the offsetting of the resistances due to meter loading means that the circuit may not even properly operate while it's being tested. Consequently, we would need to have a meter that's closer, maybe 10 megohms, and divide that in half, and keep in mind that our voltage probably might become 2.5 volts. If we were to increase it to a 22 megohm resistor, a lot less current would be going through the meter, and more of the current going through here. It would be closer to the 5 volt mark. That's why reading a schematic and having those available are very important. Plus, looking at a circuit and knowing how to evaluate what kind of voltages you should have in that particular circuit. Meter loading requires much higher resistance than what it is measuring across. If this were an electronic circuit at 10 megohm, same thing. The meter, if it were too low in its internal resistance, that is the resistance across the two leads that's going out across the resistor or the load, or the circuit, might not just read what it needs to. It needs to have at least enough resistance inside the meter to not affect the circuit that is actually being tested.